Hello students. Have you ever been to a place where a lot of waste material was piled into huge heaps? If you go to such a place, you can see something exciting happening. A crane moving towards the heap of junk, and when the long hand of the crane lowers a block over the heap, it will move. After a while, many pieces of iron junk will stick to that block as it moves away. So students, can you guess what is happening? If you thought about magnets, you are right. There is a magnet attached to the end of the crane that was picking up iron from the junkyard. So today, we will read about discovery of magnet, magnetic and non-magnetic materials, poles of magnet. You may have seen magnets and have enjoyed playing with them. Have you seen stickers that remain attached to iron surfaces like almirahs or doors of refrigerators? In some pin holders, the pins seem to be sticking to the holder. And while closing some pencil boxes or purses, they shut tight quickly without you even locking them. Such stickers, pin holders, and pencil boxes have magnets fitted inside them. If you have any of these items, try to find the magnets hidden inside them. So students, how was magnets discovered first? Let us learn. It is said that there was a shepherd named Magnus who lived in ancient Greece. He used to take his herd of sheep and goats to the nearby mountains for grazing. He would take a stick with him to control his herd. The stick had a small piece of iron attached to one end. One day, he was surprised to find that he had to pull hard to free his stick from a rock on the mountainside. It seemed as if the stick was being attracted by the rock. The rock was a natural magnet and it attracted the iron tip of the shepherd's stick. It is said that this is how natural magnets was discovered. Such rocks were given the name magnetite, perhaps after the name of that shepherd. Magnetite contains iron. Some people believe that magnetite was first discovered at a place called Magnesia. The substances having the property of attracting iron are known as magnets. In any case, people now have discovered that certain rocks have the property of attracting pieces of iron. They also found that small pieces of these rocks have some special properties. They named these naturally occurring materials magnets. Later on, the process of making magnets from pieces of iron was discovered. These are known as artificial magnets. Nowadays, artificial magnets are prepared in different shapes. For example, bar magnet, horseshoe magnet, cylindrical, or a ball-ended magnet. Let us see the effect of a magnet through the help of an activity. Let us take a plastic or a paper cup. Fix it on a stand with the help of a clamp. Then we place a magnet inside the cup and cover it with a paper so that the magnet is not visible. Now let's attach a thread to a clip made of iron. Let us take the other end of the thread and fix it at the base of the stand. Then we bring the clip near the base of the cup. The clip is raised in air without support, just like a kite. Now that we know what the effect of a magnet is, let us learn about magnetic and non-magnetic materials. Again, let's take the help of an interesting activity. Let us walk in the footsteps of Magnus. Only this time we will change the positions of the magnet and the iron. There will be a magnet at the end of our shepherd's stick. We can attach a small magnet to a hockey stick, walking stick, or a cricket wicket with a tape or using some glue. Let us now go out on a Magnus walk through the school playground. What does our Magnus stick pick up from the school ground? What about objects in your home or in your classroom? Collect such various day-to-day objects from your surroundings. Test these objects using your Magnus stick. You can also take a magnet, touch these objects with it and observe which objects stick to the magnet. Now, you can make a list of the objects that are attracted by a magnet and the materials from which these objects are made. So students, do you notice any material common in all the objects that are attracted by the magnet? We understand that magnet attracts certain materials whereas some do not get attracted towards it. The materials which get attracted towards a magnet are magnetic. For example, iron, nickel or cobalt. The materials which are not attracted towards a magnet are called non-magnetic. So students, some magnetic materials are spoon, paper clip, nail, coins, scissors, and some examples of non-magnetic materials are paper, glass, plastic, rubber, and wood. Now students, let us do one more activity. Rub a magnet in some sand or soil. Then pull out the magnet. Do you see some particles of sand or soil sticking to the magnet? Now gently shake the magnet to remove those particles of sand or soil. Are there some particles still sticking to it? These might be small pieces of iron called iron fillings picked up from the soil. Through such an activity, we can find out whether the soil or sand from a place contains particles that have iron. Try this activity near your home, school, or any other place that you visit. Now, you know all about magnetic and non-magnetic materials. Let us now learn about the poles of a magnet. So we have seen how iron fillings stick to a magnet rubbed in soil. Did you observe anything special about the way they stick to a magnet? Let us find out through the help of an activity. Take some iron fillings and spread them on a sheet of paper. Now, place a bar magnet on this sheet. What do you see? Do the iron fillings stick all over the magnet? Or do you observe that these iron fillings get attracted to some parts of the magnet more than the other parts? Remove the iron fillings sticking to the magnet and do the activity once again. Do you find any change in the pattern with which the iron fillings get attracted to the magnet? You can do this activity using pins or iron nails instead of the iron fillings and also with magnets of different shapes. Students, we find that most of the iron fillings are attracted towards the two ends of a bar magnet. These ends are the poles of the magnet. Try and bring magnets of different shapes and check for the location of the poles on these magnets using iron fillings. So, were you able to locate the poles? Let us summarize what we learned today. Magnetite is a natural magnet. Magnet attracts materials like iron, nickel, cobalt. These are called magnetic materials. Materials that are not attracted towards magnet are called non-magnetic. Let us revise what we learned today and discuss some questions and answers. Artificial magnets are made in different shapes such as, the answer is bar magnets, horseshoe magnets and cylindrical magnets. Next, the materials which are attracted towards a magnet are called, the answer is magnetic materials. Paper is not a dash material. Paper is not a magnetic material. State whether the following statements are true or false. Artificial magnets were discovered in Greece. It's false. Natural magnets were discovered in Greece. Next, maximum iron fillings stick in the middle of a bar magnet when it is brought near them. This is also false because most of the iron fillings stick to the two ends of the magnet. Next, rubber is a magnetic material. This is also false. Rubber is a non-magnetic material. I have one more question for you. It was observed that a pencil sharpener gets attracted by both the poles of a magnet, although its body is made of plastic. Can you name a material that may have been used to make some part of it? The blade of the pencil sharpener is made of iron, and as iron is a magnetic material, it gets attracted by both the poles of the magnet. Where are poles of a bar magnet located? The poles of a bar magnet are located at its two ends. So students, today we learned all about discovery of magnet,